It,
Oh, there
it
it is.
is already.
Okay. So let's start with a prayer. I could start with a prayer if you want, okay?
Okay.
Yeah.
Dear Heavenly Father, we thank you for this day and for all the blessings that you give us. Please help us in this meeting to understand and to learn with each other and to apply all the knowledge and all the study that we did. Please help in our particular lives with our families to overcome all the challenges and to be faithful in all things. And we say these things in the name of Jesus Christ. Amen.
And so preparation assignment part 1. Okay.
We need to classify like unusual or not unusual. For the first one, I wrote unusual for A.
0 point.
Yeah, A is unusual.
Okay.
Yes. So for the second one, let me see. For the second, it's not unusual.
Yeah.
For B, it's not unusual.
Yeah.
Right.
Has a Z of minus 1.059.
Mm-hmm.
Okay.
And then C, I have not unusual as well.
Yeah.
Okay.
And for the D, I chose an unusual.
Yeah.
Like the A.
Yeah.
Okay. So the second one, find the probability that a random select professional baseball player will have a batting average that is greater than 0.335.
0.015.
Yeah, I have the same answer. Drew, do you agree?
I did not get that.
No.
I have 0.2 or no. I don't know how I got that. How'd you guys do that again?
.015.
All right.
So, 3. Provide a brief description of a normal density curve. Describe the shape and the properties. So it is a bell shape. It has a bell shape, and the total area under the curve is equal to 1, and the density curve always lies on or above the horizontal axis. So it is symmetric, and it is determined by its mean and standard deviation. I don't know if anyone has something more to say.
I don't have anything else with that one.
Yeah.
Okay. Who wants to say number 4?
I can read number 4.
What did you?
In the following z-score formula, it's got the equation. Please state please state what each symbol stands for. Sorry.
Mhm.
So Z
Is the z-score.
is the standard deviation, right?
Yeah.
Z? Z?
Yes.
It's
Yeah.
the,
Yeah,
no,
I
it's,
have Z as the standard Z deviation.
no, Z, it's the z-score. Tells us how many standard deviations away from the mean a certain observation lies. How many standard deviations away from the mean? The z-score. The denominator, it's the standard deviation of the population.
Okay.
So the x is a data point. It's an observer data point. It's a number. X minus, I don't know how you say it, that symbol. X minus something. That's mean.
So I have I don't know, the very last symbol as the standard deviation.
Yes, of the population. Yeah. I have also
The
the same.
last symbol. Yes, the last symbol.
Like a O.
Okay, that's the standard deviation, not Z.
Okay, so what's Z then?
Z, it is the z-score, and it tells us how many standard deviations away from the mean
Okay.
certain points is. How many standard deviations away from the mean? It's the z-score.
Okay.
I'm confused.
So,
Okay.
so I guess I don't know how to explain it without like being able to show it, but
Mhm.
the thing that's in the denominator, that symbol there,
Yeah.
that's what stands for like what the standard deviation is,
Okay.
right?
Yeah. Yeah.
And then so Z is what we're trying to find out with the formula,
Yeah.
and it's how many standard deviations it is away from the mean.
Yes.
So from the middle, how many standard deviations away is it? Is it 1? Is it 2? Is it 1.5? Things like that.
A certain point. And the point it's given us by dx.
Does that make more sense?
Yeah.
I think so, yeah.
Yes.
Okay.
Não. Gente, eu não tô falando que achei que cedo.
Okay. Should we do number 5 now?
Yes.
In no less than 3 sentences, please define and describe 68 through 95 through 99.7 rule.
So in a bell-shaped distribution, in a normal density curve, 68% of the data it's within one standard deviation of the mean from one side and from the other side. One standard deviation from the mean.
And for 95%, it's 2 standard deviations of the mean.
Yes, it lies within 2 standard deviations of the mean.
And for the last one, the 99.7, this is 3 standard deviations of the mean.
Oh.
Yep.
Okay, let's go to part 2.
Row.
So for this one, I saw the videos of our teacher. I don't know if you already saw it in the announcements.
Yeah, I watched
And
some.
yeah, and she teach how to make the design, but it's a bit confused for me. But let's try. When I saw the video, it's easy to understand, but after applying in the exercise, it's other talk.
So we're on
So,
5,
6.
right? Or 6?
Yeah.
Did we read that already?
No.
Let me do the math.
So the mean is 150.8. Standard deviation is 8.8.
Yes. So
For the scores, and for the speed of hydrogen, it's 1800, and the standard deviation is 600. So number 6 is the mean of all quantitative scores on the GRE is 150.8 with a standard deviation of 8.8. A says scores on the quantitative portion of the GRE are approximately normally distributed with mean equals and standard deviation equals. So the mean equals 158 and standard deviation is 8.8. So that's for A. That makes sense, right? Because that's what they gave us on the table.
yes.
Okay.
So, but what
So
they
B,
want for us to say it is true or false?
it's just asking us, because on the thing it asks us what the mean is and the standard deviation, but I mean it tells us twice what it is.
Yeah.
So B says, what portion of the people who take the quantitative portion of the GRE will score above 165?
So right now we need to do the design, right? The bell shape and the
Shouldn't we use that graphic with colors? That graphic.
apple.
Yes.
I have mine open it.
So if you put he wants to know the score above 165. So you must put the blue zone in the right zone. So
On the right?
this score is 1.6. It's that 1.6136. If you put this score, do you have your open?
Yes.
So if you put this score there, what is the number that it gets?
What is the number that you said? 151.3.
1.6136.
Sorry, say it again.
1.6136.
The area tells that this is 0.87.
Sorry?
On the area, it shows a number 0.87.
Can you share?
Yes.
It's the other one, Cidalia. It's the right one.
But I put other number. I don't know why.
Ok. Cidália, é a parte azul do lado direito, só. Tirar do meio. E esse é o Z-score?
The number changed. You say
1.6136.
And the numbers change, you see? I put a number and the number...
and if you put in the area 165.
What is the number?
165. Yeah. The area, it's between, okay.
So what we have to do is we have to find out what the Z-score is.
But
with that equation that we have.
The Z-score. We have the Z-score. The Z-score is 1.6136.
Okay, so then you got to type the Z-score in that area. Not in the area format, but in the Z-score format.
The Z-score.
What is the number?
Gina, okay, ele arredonda. He's rounding. That's why he's changed the number, because he's rounding.
That's right. What you have down there, 1.614. I'm pretty sure that's right.
See, I make some annotations that she share on the video. Sim, so. Okay. Maria lost the internet and she's calling. We wait a few seconds. But it's saying, está a dizer direto mesmo. Deves conseguir entrar na mesma.
So put in the...
Sound, ele está a falar, deixa-me depois. Entra pelo Skype assim, está bem? What, Roberto? Sorry. Maria is calling to saying that she was start her computer. So I'm sorry.
Okay.
So you
So-
are saying that.
So, yeah, the z-score equation
Hmm.
equals 1.6136. So if we type that in there, okay, so it rounds it.
Yeah.
And I think we want, what is the question asking? What portion of people who will take the be above? Yeah, so that's right. If you just click enter, see the area above, it says 0.053.
Mm-hmm.
That's our answer.
Okay.
So that's the percentage or the probability of people that are going to get above a 165.
53.3%.
So 5.3%.
Oh, okay.
Does that make sense?
Yes.
So if we just do the equation where it's 165 minus 150.8, so you do that first, and then you divide it by 8.8, you get the 1.6136, but it rounds it to 1.614. And if you just click enter with that blue portion above, then it gives you the answer with the area. So the area, which is our answer, is 0.0533 or 5.3%, which however you want to look at it. But that's the answer, the area is.
Okay.
All right, that makes sense.
Okay. Okay. Do we want to keep going on these questions?
Yeah.
Yes, because I didn't understand them very well.
Okay.
If you don't mind, if you don't bother to
Okay. C, if a student's score is the 10th percentile, what would their corresponding z-score be?
So we need to put the 10 here.
No, because the area has to be between 0 and 1. No number greater than 1 can go in the area,
Mhm.
because that's like the probability. You got to follow the bell-shaped rule. So what's the 10% going to be?
What is the 10% of?
So the question is asking if a student's score is the 10th percentile, what would their corresponding z-score be?
How do you find it?
Percentile.
Where'd you get 10th from? My paper doesn't say that.
Oh, that's what mine says in 6C.
Yeah, not mine.
What does yours say?
Just says what is the percentile that would be corresponding z score b.
Yeah, mine says 10th. I don't know.
Yeah, mine is
Yeah,
says
mine
10.
is the same 10,
Okay.
10%.
So it's basically I'm pretty sure 10th percentile is like the top 10%. That's what we're trying to find. Right?
on the video, don't explain about the percentile, how to do it.
But what is the equation for this? Find the z-score. Because I have the result, but what is the equation? Does anyone knows?
So all I know is how to do it on the,
On Excel?
not on Excel, but that template thing that she gives us.
So what do you put in Excel? Percentile?
Could you share your Excel, Roberto?
Yeah.
Right, it's better for us to follow your thoughts.
Because in the Excel, to do a percentile, you need an array.
Is mine sharing?
Not yet.
It should be on there. If you just click on mine.
No. Ah, it's there. All right.
Okay, so if you just type in area 0.1, that's the 10th percentile, right?
0.1. Okay. 10%.
It gives you the z-score at the bottom.
I think it's the same. Let me see.
Oh, and I put 10. This is the wrong, right? I should put 0 point.
0.1.
Okay.
Yes. For 10%. So, oh,
That's
we
the
need
answer.
this graphic for the quiz. Yes, yeah. So that's the z-score. That's one of the answers. So the next question is, what is the quantitative GRE score for a student who scores at the 10th percentile? So we have the z-score. That is
Yeah.
Robert, I think it's the left side, not the right side, because it's not the top 10. It's only the 10th percentile.
Okay. Either way, it's the same. It would just be negative.
It's negative. All right. So we have the z-score. It's a minus 1.288. It's equal an x minus the mean. Minus the mean, and the mean is 1508 divided by 8.8. So, let me do the math. Okay. Centimeter, 162.
Yeah, that's correct.
Okay. 162. But the result that the instructor gave, it's 139.5.
What'd you get?
162. 162.
That's what you got for the answer?
Yes, but I'm going to do again. Yes. 162.08.
Hang on, I don't think that's right.
No. Okay. No, no. Oh, it's 139. Yes. Point 52. Yes. 139.5. Yeah. Yes.
Yeah, how did you get that though?
So you have the z-score. You put the minus 1.282 equal to x minus 150.8 divided by 8.8.
Yeah, that's
So
right.
you go, yeah. So you're going to multiply the 8.8 by the z-score, and then you subtract the mean by that result, and it give you the x.
Yeah, that's right.
If you understand what I'm saying, but it is better show to show in the paper.
No, I got what you're saying.
You have the z-score, you have the standard deviation, and you resolve for the x.
Yep.
Okay. So number 7, the mean. So the mean speed of hydrogen at room temperature is 1800 meters per second with a standard deviation of 600 meters per second. At room temperature, the mean hydrogen particles is approximately normal with a population mean of 1800 meters per second. Understood?
Yeah.
Equal. I don't know why they repeat. What is the probability that a random selected particle has a speed over 2,500 meters per second?
So
Okay. Do we need the graphic? Probability. Okay.
this is what I got.
How do you find score? Z-score.
So you find the z-score using the equation. So z equals.
Okay, dx is the 2500.
Say that again.
The x value is 2,500 meters.
Yeah. Yeah.
Okay, I understand. Okay, thank you. Yeah.
So the area is the answer. That's our probability, 12% or 0.12.
Yeah, that's the result here. So the next one, C, what is the probability that a randomly selected particle has a speed that is less than 2,500? What do you do? It's the difference 1 minus 217. It's
So
the difference.
less than. This is our answer.
So what you put 1 minus the
It selects the other area.
I just selected the area below, but you could do that. You could do 1 minus what the probability was before.
Okay, that's what I did.
But yeah, this is the same answer.
Yes, it's the same. Okay, just for me to understand. Okay, so thank you. Sorry, I appreciate the comprehension. So number D, what is the probability that a random selected particle has a speed that is less than 1,500? So you need to find the z-score for this one and then put it on the table. So
0.4, right? .480.
This is the actual answer. Sorry.
Well, could you just divide though? Half it or no?
So what you have on the graph right here, this is what the answer is.
Let me see.
Oh, I just figured you could divide. And then
Do you get the same answer?
And I saw yours and I thought, oh, okay, that must be it.
Because the answer is 30.8% or 0.308.
Yeah.
So again, you find it by finding the z-score.
We need. We need.
And then you type the z-score in, and it gives you the percentage, the area.
Yeah. But first you need to find the z-score. You need to do the equation to find the z-score. Yes,
right.
I'm understanding right now.
So the z-score was -0.5. So you type that in here, and then it gave you the area. So the answer is 0.3085.
I need to buy, but Saturday I will work, so I don't know when I could buy my new glasses. It's a trouble for me. I'm struggling with it all day and night.
Okay. For E, so what do? You subtract the C minus the D the result from the C minus the result from the D. Let me see if I'm thinking correctly.
Yeah, 0.87 minus 0.30, I think is the...
Yes, it's correct. Yeah.
So you subtracted what? You subtracted
the
result
answer of
from
C from
C
D,
and D.
Yeah.
and you got 0.56.
Yeah.
Uh-huh.
9x.
Okay.
Yes.
Okay.
This is our answer for E.
Okay. Yeah,
Okay.
that's right.
Yeah.
Because we have the number of 2100 and the other one.
Yes, because he wants to know the probability of a number less than 200 and 2,500, and the probability of a number less than 1,500. So
Yeah.
now he wants to know the probability between the two, a number
Okay.
between the two. So
Right.
you subtract.
So let's go to the
Hard
F.
to talk in English. Sorry, it's better to talk in Portuguese. You must learn.
So third
What is the
quartile.
third quartile of the speeds of hydrogen at room temperature?
So we need to put the 0.3 in the area, right, Roberto, like you put in the other answer?
I don't know. I'm confused by this one because it's just saying what is the third quartile. So yeah, it's like what we did.
The third quartile. So what is the z-score for this? It's the... Okay, let me see what is the z-score. Third quartile. How much?
I'm a little bit confused by this question.
Yeah. Okay. Just remember me. How did we did the D from the exercise 6?
How did we do D?
The D from the exercise 6, because we had the 10th percentile.
Right.
Cidália, lembras-te? Do you remember,
So
Cidália?
I remember how we did D.
Okay.
We put in the area 0.10.
Right.
So right now I think we should put 0.3.
Yes,
0.03. Yeah.
Yes, the third quartile.
Why 0.03?
No, it's different. We have to put 0.75. Third quartile is 75%. It's not in the D from exercise 6, we put the 10th percentile. Now we have the third quartile. It's 75%.
He's trying to put the number.
Oh, sorry, I'm not seeing it. I'm looking at the exercise.
It just keeps going back to 0.
Yeah.
75. Quem tirou? Eu vou falar com ele, tá bom?
Is
Yes. And this score for that it's
like that? Is that?
It's not our answer.
Okay. I think I got it. Hang on. What was the mean?
the mean is 1,800.
And the standard deviation was 600?
600.
Sorry.
Okay. So I found the answer. So you take the z-score. So this was right, what we did here on the chart. So you take the z-score of 0.674 and you plug it in. So that is z. So that equals x minus 1800 over 600. So then you multiply by 600 to the z side, and that gives you 400 and something, 400 and some change. And then you add the 1800 to both sides so that you get rid of the 1800, and then it comes out to the correct answer of 2,204 equals x.
So
does that make sense?
You did the math for the x.
Yeah.
So how do you come with the z-score? With that value of the z-score?
We came up with the value of the z-score from what you said, putting 75 into the area. And then this gave us the z-score.
Yeah.
And then you use that z-score to do the math for the x.
Right.
All right. Thank you. Okay, let's go to the next one. I think we finished, didn't we? I don't know.
I think we should start on the quiz. We've been
1 hour.
For an hour already.
Yeah.
Yes. Empresta mãe que caneta agora, dá uma caneta à mãe.
Are we moving on?
Yeah, we're going to the quiz.
All right. We got it open already.
Okay. Pode empunhar, tá bem, Francisco?
So the question 3, the total area under normal distribution curve must equal, I think is 1.
Yeah,
Right.
it should be 1 because that's what the total should be.
Yeah.
I agree.
Okay.
So
Number 4, it says under certain circumstances, a normal distribution curve can drop below the x-axis.
false.
It's false.
Okay.
The rule has to be above, right?
Yes. Must be on above.
Above 0 or something. So question 5, a normal distribution curve is symmetric.
Yes, it's
Yes, I
metric.
think so.
True.
Yeah.
True. So question 6, which of the following elements of the figure represent the z-score?
C.
Easy. Yeah. Pretty easy.
Yeah.
Question 7, which of the following elements of the figure represents the probability that the z-score will be greater than 1? B, right?
Yeah, I think so also.
Which of the following?
Which of the following elements of the figure represents the probability that the z-score will be greater than 1? It's
Yeah.
B.
B.
The
So let's go for the 8.
So number 8, according to the 6895 97.7 rule, what percentage of the data from a bell-shaped distribution will be within 1 standard deviation of the mean? Write your answer as a percentage such as 42 rather than a proportion such as 0.42.
So the answer is 68, right?
Why do you think is 6, 8? Oh, right.
Because
What is
that's the
Yeah.
percentage within 1 standard deviation.
Yeah, sorry. I don't read
Okay.
That's.
well the question.
Do we agree on that one?
yes.
Okay.
For the 9.
So question 9, suppose that the z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between -1 and 1? Give your answer as a decimal accurate to 3 decimal places. If the answer was 0.389184, you would enter 0.389.
I have 0.683.
Sorry. I have 0.3173. It's the same.
I already have that one. 0.3173.
Okay.
With the score.
How did you get 0.313?
I put on
with
the
the zeros
score
with
one.
a z-score of -1 and 1, the area between the two scores.
If you go to the bell shape.
Sorry.
Sorry.
A standard deviation of 1. The area between it's 0.3173 in the norm in the applet.
I'm confused at how you guys got that answer.
Yeah, I'm confused too. I'm 0.683 or something.
I will, if you want, I share mine to see.
If you could.
Okay, just a second. Let me. Okay, let me see if I could. Okay. You see, I put here in z-score 1, and in the area, it's showing 0.3173.
But the question is asking between -1 and 1.
Yes.
That's outside of -1 and 1, not between -1 and 1. So if you look at mine.
Yeah, you're right. You're right.
Mine is the one that's between.
Yeah.
Oh,
right.
Sorry.
You're looking from the outside part.
Right.
Okay. Thank you. 0.
Yeah.
This is 9.
Okay.
Oh.
So number 10, do you guys mind if I keep reading?
Yeah, I don't mind.
All right. Suppose that z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between -2 and 2? Give your answer as a decimal, accurate to 3.
Okay. I have 0.9545.
That's what I got as well.
Yeah, okay.
I did not get that. Hold up. Oh, no, I did.
Are you agree? Are you seeing my
0.9549?
Yeah.
0.9545.
Yeah. Okay.
How many?
Does she still want us to go 3 decimal places, you think?
Oh, sorry.
You want 3.
Yeah, 3.
So it's 0.9555.
Yeah, round up 55.
Yeah.
0.955.
And the other 2. And the question 9.2.
Sorry?
Conheço 3 casas decimais na questão 9, Tina.
So the next one's the same question.
0.683. Okay, thank you.
So number 11 is the same question, but for z-score of -3 and 3.
Okay, I have
So
0.9973.
That's what I got as well.
Yeah. So
0.9973.
So we put 0.997, right?
Right.
Okay.
Does it matter if we put the 0 point, or can we just put point?
On the example, she had a 0 point, so it didn't matter last time, but I'm just doing it just in case.
Mhm.
So number 12, look carefully at your answers to the last 3 questions. What do you observe? I don't know.
It's the first one. The values match the 68, 95, and 99.7 rule.
Right,
Okay.
that's what I got.
Yeah, it's our answer. The first one. It's easy, right?
All right, next question. So the amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of number of grams of good quality protein that must be consumed each day per kilogram body weight. The population mean protein requirement for adults is 0.65 grams, and the population standard deviation is 0.07 grams. What proportion of the population have a protein requirement that is less than 0.6? Give your answer as a decimal accurate to 3 decimal places.
What is...
So the z-score it's minus 0.714. So we can go to
The z-score was what?
minus 0.714. And he wants to know less. So the area, I think it's the probability it's 23% and 23.76.
That's what I got.
Yeah.
What? Sorry, could you share?
Yes, I can.
Because when you say the numbers, it's for me. It's
Well, I did math to find z-score.
yeah. So you take the 0.65 minus 0.07, right?
Now 0.60 minus 0.65 and divided that by the standard deviation of 0.07. And I got minus 0.714. And then I put that value as a z-score in the graphic. Let me see if I...
Yeah, I didn't get that, but that made sense, I guess.
Here, I'm sure. Sorry, I'm not sharing. Cidalia, are you seeing?
Yeah.
So
Okay,
minus
we put
0.714 was z-score, and he went less than 60. I think this is the area, and that's the probability.
Okay, thank
Right.
you. Thank you.
You're welcome.
All right, so we're all good.
Yeah.
What proportion of the population have a protein requirement that is more than 0.60 grams? Give your answer as a decimal, accurate to 3 decimal places.
So I have it on mine.
It's the difference between it's 1 minus that number.
Right. Yeah, you can do that, or you can just do the highlight the top portion.
Shows 0762, right?
Yep.
All right, number 15. What proportion of the population have a protein requirement that is less than 0.70 grams?
So just check with me number 14. It's 0762.
Yeah.
0.762.
Yes.
Okay.
That same. Oh no, it's not.
So this next question is the same answer.
So
Pretty sure.
0.762.
Hang on. I just want to make sure. Actually, it might be different.
So the z-score is 0.714. Positive.
Right. Yeah, so it's the same answer. So what's less than that? I have it up on my screen.
Let me check the question. I think can you see mine? I think it's
0.762. Yeah, that's right.
Is that correct?
That's
So
what I have.
It is
If you
the
look at
same
mine as well.
answer. It is the same question. The same answer.
Yes,
It's the
correct.
same answer as number
14.
the one above, number 14, yeah.
Yeah. Okay.
Yeah. Okay. Yeah.
16. Find the probability that a randomly selected person will have a protein requirement that is between 0.60 and 0.70 grams. Hint, remember that find an area between two values, shade to the left of each z-score you calculate, and then subtract the smaller area from a larger area. Make sure your answer is positive. This is a probability that a randomly selected observation will lie between the two values. Give your answer as
Oh, sorry.
I'm good. 3 decimal places.
It's subtract 0762 by the 0238.
Yeah.
Okay, just to the left then.
0524.
Too far? Or no, so 0525.
525. Yeah.
0524.
Yes, but it's rounding, so 0525, I think so.
Yeah.
25?
Yes, because the other number it's an 8. So you should run and right?
Yep.
Okay. Gina, como é que tu deu 5? Porque tu... Sorry, I'm going to speak in Portuguese. Porque tu tens 4 casas decimais.
2, 4, 8. Como são 3 casas, arredondei. porque era 0,5248, certo? Se são 3 escalas decimais, o 4 contém a seguir o 8 passa a 5.
Mas eu só tenho 3 casas decimais, como é que tu tens 4 casas decimais? Que números é que tu puseste a subtrair?
07620238. Esquece. Esquece, eu pus ali mais um número.
Pois, eu estava a ver.
Sorry, others. This is 0524. We shouldn't round it because we have we don't have other number. I'm sorry. I put other number.
I mean, I'm kind of nervous on whether we should or shouldn't round that one, because if you just did it on the chart like you see on my screen.
Yeah,
right
I see the screen. Yeah, if I
It's
put
got
the
the 0.8,
in
so
the paper, it's different, but it's in the area. I make the rounding, so
yeah, so I'm not sure whether we should round it or not.
I think we should, actually.
Well, if we subtract from the answers, it does not give that value, that decimal. But I think we should also, because it's the correct.
seeing on the map, right?
Because if we subtract those two values, they are already rounded, and it gives us a not correct number because they are rounded. We are subtracting rounded numbers, but I think we should.
Well, yeah, but you don't subtract you subtract the actual numbers, but you just.
Yes, that's why we should only now round. Okay.
Yeah, just
Thank
after
you.
I could be wrong, I guess. I don't know.
We'll see. If it's wrong, we can just change it on the.
Yeah.
We're on 17, right?
Yeah.
Find the 35th percentile for the protein requirement for adults. Round your answer to 3 decimal places.
Okay, so 35th percentile.
.385, right? And then
This is what
0.6.
We need to put the let me see, the 35, 0.35 in the table, in the label, in the
on that area.
and on the area. Sorry. What is the?
Which gives us a negative z-score of 0.385.
So we should put the minus.
Yeah. Yeah, that's z-score. So we must do the math for the x.
Right.
Okay.
Point.
All right, so you guys got it?
I got it. I think it's 0.623.
0.623.
Can someone confirm that?
1.62305.
Is that what you got, Maria?
Yes.
Okay, that's what I got too.
All right, number 18, find the 80th percentile for the protein requirement for adults. Round your answer to 3 decimal places.
So the z-score is 0.842, right?
Yeah.
And then we got to solve again like what we just did on the last equation.
Yes, we need to do that again. Okay, let's see. 80% times 0.82. See, it's 0.84.
I got 0.7089, so rounded 0.709.
I have the sign.
Okay.
It's a negative.
I'm gonna no, it's a positive because it's the 80th percentile.
Submitting mine right now.
Drew, you're submitting yours?
Yeah.
Okay.
I'll tell you guys in a second.
It's positive.
Is everything right, Drew?
Yep. 100%.
Okay, sweet.
He said it's totally genetic, no food involvement. Partial. How about that? I know, I was concerned dollar, I'm saying, oh.
Okay. Everything's right.